with the potential discovery of the ninth planet, I immediately reached out to the one person that I needed to hear from, and that was Walter. Brought him over on my show and had a great conversation. But we didn't anticipate what happened yesterday either. And immediately, Walter needed to be on this show tonight. Walter Cruttenden is the director of the Binary Research Institute in Newport Beach, California, where he researches the cause and the consequences of solar system motion. Walter is also the host of the annual conference on precession and ancient knowledge. It's called CPAC, which brings together authors and scientists from around the world discussing the implications of the precession cycle on biology, archaeology, anthropology, and related sciences. I would like to welcome back to Coast, our good friend, Walter Cruttenden. Walter, good evening. How are you?
I'm doing great, Jimmy. How about you?
Yeah, not as excited as you are. Pretty amazing times this past couple of weeks.
It really is. Yeah, two huge discoveries within a month of each other. Yeah, just amazing.
Hey, you must be giddy. That's the first thing, because you've been working on this for over 10 years. You've been shouting and presenting research and CPAC, and which is, it's all great. But then you start to get this verification of everything that you've been talking about. Pretty exciting.
It really is, yeah. You start to think maybe you're not crazy after all.
Yeah.
But, yeah, no, the emails are coming from a lot of places. People I've first started talking to this about 10 years ago, and now, people are filling in the pieces, and it's great. It started with this thought that there's this big gravitational mass out there, but the initial thought was it really couldn't be anything that we could find or see, because we know everything about the solar system. It's almost funny how science always takes this very conservative approach at first, and then the more they realized that all these minor planets were starting to line up in this pattern, the more they were forced to admit that something very big is out there and it's affecting our solar system.
And one of the things, and this is what I want to do really quick, Walter, as we lead into the first break. Let's do this first. All of this is something that you have been talking about a long time, which is gravity affects everything. It doesn't really matter about distance. There are things going on here, and we need to talk about it. And then Mike Brown hits us with Caltech 2 weeks ago with the potential discovery of the ninth planet, which he had to do because he had to replace Pluto with something, right? So he was able to detect a large body out there that was affecting lots of things in our solar system. And how important is that discovery, and what was the discovery?
Well, it's particularly important, and I think it got more attention because it was Mike Brown that was shouting about it this time. And you remember Mike, who's brilliant astrophysicist, was the guy that had been finding many of these minor planets out there, including Sedna. And so when he found many planets that started to be and look a lot like Pluto, the realization came that, boy, these are, much smaller than the regular classic planets. Maybe Pluto has been misclassified all these years, and therefore maybe we should have a big meeting of all the astrophysicists and sort of get this question straight once and for all. And so we all remember, less than 10 years ago, Pluto was sort of kicked out. It was no longer 9 planets in our solar system, just 8. And I understand that Mike's daughter was mad at him for that. And so he kept looking and finding more minor planets. But then he realized that all these minor planets he's been finding kind of line up in a very unusual pattern. And
how so? How so?
Well, he calls it a gravitational signature. And that is that if you think of the 8 classical planets, they're all within 1 or 2 degrees of the plane of the solar system. And when Pluto came along, it was discovered it's about 17 degrees inclined to the plane. And so that was strange. And then also it was noticed after a while that its orbit is much more elliptical. There's very little eccentricity in the 8 big planets, but Pluto has this huge eccentricity. It's this stretched oval. And so when he kept finding these other minor planets, they kind of all fit into that pattern. So it seems that the farther out you go and the smaller the planet you're observing, the more it appears to be affected by something on one side of the solar system. And, the evidence mounted and mounted and mounted. And I think they were looking unofficially, probably for the last 2 years, but having found nothing, they've kind of opened it up to the world now because, the U.S. Astronomers, astrophysicists are sort of in a race with the rest of the world because the Spanish astrophysicist came out and said something similar. But it was really Caltech, Mike and his team, that added much more detail to the whole idea that there has to be a big gravitational influence out there.
And then you had Percival Lowell when he was looking for the 9th or possibly a 10th, and Pluto comes along. He said, Pluto's just too small to be causing these issues that we see out there. Pluto's fine, and that's cool. But there's got to be something else. Pluto is not big enough to cause these distractions that are going on out there. And then Mike Brown hits this 2 weeks ago, and it does seem to fit, all of the questions that have been on the table.
Yeah, and so you make a good point that when Pluto was first discovered, there was a lot of talk and chatter about there must be something bigger. And then we didn't find anything for a while, so it just died down. And then, of course, our telescopes got stronger, our computers got better, and Mike and his team in the modern era, were able to find many more things, including define that the Kuiper belt sort of seems to have a shear edge to it. So there's multiple items that point to a large gravitational object out there, and I think we're just finally accepting those in mainstream astronomy, if you will.
When do you think we're going to have some, definitive proof, either through physical proof, through a telescope, but maybe imaging?
So the race is on.
Sure.
At first it was just the Spanish and Caltech and a few other people that read the research that, had access to large scopes that would be looking. But now that this is, publicly acknowledged, in news and Nature and all the top publications, there's probably 1,000 different astronomers, astrophysicists diligently looking for it. I mean, some of them still have to book telescope time, and they're looking in, various parts of the sky, although generally on just one side of the solar system.
I got a ton of email after you and I spoke last week or the week before, saying the obvious, and this is the general public, Walter, saying the obvious. What about Kepler? What about Hubble? We can see everything else at vast distances. What's going on here? Why can't we simply just point these two telescopes there? Because this is relatively close compared to the rest of the Milky Way and everything else. Right.
Well, I'm pretty much in that camp, by the way. But there is a legitimate reason why things would be difficult to see. And, one is it could be a very cold object, almost a planet-like mass, and therefore just not showing up very well, particularly if it's covered with dust, not reflecting light. Or it could be an object, hidden with the sort of the glare of the Milky Way. Or it's possible, that we just haven't tracked that part of the sky for long enough. But the longer this goes on, the weaker those excuses become.
Exactly.
Yeah. And so that's what kind of gets back to our original hypothesis, which, yes, there's a big gravitational influence, and yes, it's stretching our solar system, but no, it's not a planet, and I don't think they're going to find a planet anytime within the next couple of years, and that will then lead to, well, the influence is still there. What else could be causing it?
And then what about, here's the elephant in the room for all of our coast-to-coast audience and the readers of the 12th Planet and the fans of Sitchin's work. Is this what Sitchin was talking about?
Well, I think there's different interpretations there. Sitchin, he not only looked at some of the modern astronomy, but he also looked at very ancient texts and mythology, and I think that some of what he's interpreting could have slightly different interpretations. And I don't want to cause any uproar or anything, but even the word Nibiru has been interpreted differently by different people. So, hats off to Sitchin for putting the argument forward, getting a lot of people thinking about it, talking about an object. But I don't think that the periodicity of the orbit fits very well with what he's talking about. And so I look to, a different explanation using some of the same data.
Where did Mike Brown, and I'm sure you've looked at his data, where did Mike Brown get his orbit time and sequence from those calculations? Because isn't that a 10,000 to 20,000 year orbit? That's a pretty wide band of numbers. Have you had a chance to look at that data?
Yeah, and the longer they look at it, the more they can narrow it down. And I think it's pushing more and more towards the upper limit as time goes on. But remember, you have to look at more than just a few arc seconds or even few arc minutes to start to understand the ellipse. And so that's effectively what they're doing, is they need to watch it long enough to determine the orbit periodicity.
Well, we have a paradox here, at least with me, which is I want it to be a 20,000 year orbit. I want it swinging by here every 10,000 years, because then we really get crazy with questions and answers. If it is a 10,000 year orbit and we're looking at it swinging by here every 5,000 years on the far side of our sun and solar system, it's cool, but I don't think it has the historical impact of a 10,000 year cycle coming through and affecting gravity. For me, you have precession and a bunch of other things that happen cyclically at that 10,000 year cycle. And although it seems like a reach, I think it's a strange coincidence.
Yeah. So, my feelings on it. I think it's going to be towards the upper limit, even a little bit beyond, because it fits the precession data and other data so well. And in fact, this whole concept of time that we use nowadays with two 12-hour periods that adds up to a total of 24 is a very, very ancient idea. We can only trace it as far back as the Egyptians and the Mesopotamians, but really nobody knows where it came from before that. It fits very well with some ancient Indian data too, in the laws of Manu. But anyway, it would appear that if it's 12,000 years out and 12,000 years back, a cycle of 24,000 years, then it fits the precession data very nicely, and it suggests that our current concept of time is actually a microcosm of this great year, if you will. And that has a lot of significance.
It's a whole nother class and degree in college, if it does open up those doors, if you think about it. And the implications of the binary system, a binary star system for us, is there a possibility that this could be a brown dwarf or a gaseous giant that could have been another star here at one time and got cut loose out of the solar system for whatever reason?
Yeah, it could be. I mean, if it's a brown dwarf or a star, you would still call that a binary system. But yes, it could have definitely been closer at one time. And so there's this whole field of research going on that, it's a planet or a very small star, and we just haven't seen it yet. And I think that's the most logical or the easiest thing for mainstream science to accept right now. But again, to me, if you pull in even more data, the unexplained forces acting on the space probes and the precession data, et cetera, then I think you want to find one solution for all that. The fact that our whole system is curving through space would say that we're in a binary system, and it must be a pretty significant mass to essentially stretch the minor planets out in such wide orbits.
This is some of the most exciting times I've ever been in. I never would have anticipated something like this in our lifetime. This has been a really crazy roller coaster a couple of weeks when it comes to physics and astronomy. And we're going to be heading towards a break. What I would like, really quick, what is a binary star system and why is it so important?
Well, good point. Yeah, some of the basics. So,
yes,
a binary star system is two stars gravitationally bound, orbiting a common center of mass, and that center will be closer to the largest mass. And 50, 100 years ago, it was thought that these things are pretty rare. And then as telescopes got better, people realized, oh boy, they're all over the place. And it has gone just in my lifetime from about an estimate of 50% of all stars being binary, now up to 80% of all stars being binary.
And why would it be? Why would it make us so unique? I understand that we would be 10% of everything, but are we truly unique if we don't have that binary star?
I think we are. I think stars like companions as much as people do.
Walter Cruttenden, director of the Binary Research Institute, Newport Beach, California, is our guest tonight. And when we come back after the break, the big news, gravity waves. Albert Einstein was right. I'm your host, Jimmy Church, and we'll be back right after this. All right. One of the great things about doing this show is this is late night talk radio. And that's all I used to do growing up, listening to shows like this, just thinking one day, I'm going to be able to, just one day. And now I get to do that. I get to paint that picture for you. Right now, we are in the studio here in Los Angeles. The lights are turned down. It's dark. That's what you need to do. Turn down the lights and then enjoy that bumper music because I get to choose it and just paint that picture for you. Two very interesting things have happened over the last couple of weeks. Yesterday, one of the biggies, gravity waves discovered. Albert Einstein referred to this in his general relativity. We're going to be talking about that more with Walter Cruttenden right after the break. And then next week, come and meet George, Tom, myself at the 14th Annual Conscious Life Expo. It's right here in Los Angeles at the LAX Hilton. It's going on February 19th through the 21st, right here in Los Angeles. Just go right now to ConsciousLifeExpo.com. Get yourself some tickets. Get the video live streaming. Come and visit us. I'm your host, Jimmy Church. More with Walter Cruttenden right after this short break. Stay with us. Welcome back to Coast AM. Walter Cruttenden is the director of the Binary Research Institute right here in Newport Beach, California. And we're discussing the recent astronomy and physics discoveries over the last 2 weeks. And yesterday, the big announcement came, gravitational waves. Walter, let's go straight there. The first question I have, if everything adds up and everything is correct, could E.T. ride these waves and get here to Earth?
I don't know. Is he out there?
Yeah, it's the obvious question, right? And is this something that we could use to go there?
Boy, I'm just elated because it gives us a different way to look at the universe. We've had optical waves, through telescopes, visible light for, a couple hundred years. Just really gotten good in the last few decades. And then X-ray telescopes and radio telescopes, but all those are using the electromagnetic spectrum. And so what's unique here is we now are effectively have a way to see things with gravitational waves. And so just as X-rays and radio telescopes gave you, a new view. You didn't just see the visible light of, a few stars scattered amongst a mostly black sky. You saw, massive auroras and a much more active and violent sky. I'm imagining that using the lens of gravitational waves, we'll be able to see things that we didn't know existed. And I'm not sure what they are, but it probably, you're going to see different ways of looking at the universe, different structures that we can hardly imagine.
Well, the LIGO discovery, which the announcement came yesterday, and when I looked at their numbers and the graphs that they presented and the description of it, I had a hard time wrapping my brain around. I thought I was going to go, okay, I get it, I understand. But these are very, very small measurements that actually did come in waves. Can you describe that to the audience so they understand how they made sense out of this and actually observed a wave?
I'll do my best. So they use basically light and mirrors, interferometer, to measure, over a distance. And then they compare them to each other. And if there's a difference in them, and they have them at completely different ends of the U.S., one's in Louisiana, one's up in Washington State, that it means, and yet they get the same sort of signal in each one, it means that something has effectively passed through the Earth and slightly thrown off this measurement of the speed of light effectively in two different locations. Now, I happen to think that there's an easier way to do the experiment, and it's probably hubris on my part, but I ran into a guy in Canada a decade or so ago, a brilliant man, Karl-Heinz Hohmann. He had the Sirius Research Group, and he had something in his basement for over 20 years, and that was a fixed telescope, in cement, always pointed out the window towards Sirius, which is pretty low in the sky from Canada. And the telescope had dust on it because, just didn't want to ever touch it. And then right next to the telescope, he had a radio with the atomic time from Fort Collins that would give you a beep, every X seconds. And then the telescope had a crosshair on it, and so it was pointed towards Sirius. So if you think about it, it's fixed on the Earth, but the Earth is spinning. So every sidereal day, every 23 hours, 56 minutes, and 4 seconds, Sirius would come around. And so I remember being at his house, and we were having tea, and he says, "Oh, Sirius is about to come around. I want you to take a look." And sure enough, it's going through the crosshairs, and he's measuring the time exactly. And what he found was that the Earth spins at a very even rate, except when our nearest one of our nearest binary systems, certainly our largest near binary system, the Sirius system, Sirius B goes around Sirius A. And when that comes in between, the Earth actually slowed down for about a second the day before it passed, a couple days, and then it sped up that second in the next couple of days. And so it's a different way of doing a similar experiment, and that is he was using the entire Earth and rather simple equipment, and then he didn't even know to expect this. It just so happened that Sirius B going around Sirius A,
right?
It happens it's a 50-year orbit. And it happened during his measurement time, and that's when he noticed, and he started to look at the literature and found out that something similar had been discovered last time it happened. So I think it's just a cool way of measuring gravity waves, which when Karl Heinz was doing it were thought not to exist.
And what's interesting here for me, Walter, is all of this back in the early 1900s when Albert was putting this together. It was math. It was in his brain. It was in his mind, and he proved it, or got the theory going in general relativity that gravity waves existed. But again, it was in one man's mind, and it was presented in math, and that they had to be there. And I find that totally fascinating, and for it to actually happen as it was presented in one man's mind in theory and presented to the scientific community, here we are 100 years later, boom, it actually proved to be, not only real, but happening.
No question. I mean, the guy is one of the greatest scientists that ever lived, absolutely brilliant, and he could see these things in his mind. And he could speak this unique language of math, and he's a pretty good mathematician, I hear.
Yeah, right.
And so he, could communicate it to the astrophysical community, and even at the time, there were very few people that understood it. But as years passed, more and more people began to understand the implications, and of course, it was a totally new way of looking at gravity.
And I want to understand too as well, because I've seen the illustrations, I've seen some animations about this, but can we paint this picture for the audience, if you will, Walter? Is it like a wave of water, and like a surfer would ride that wave? Is this what we can visualize? Does this help us try to picture what's going on?
If you remove one of the dimensions, it's easier to put your head around. So and that's what they do in these pictures you see on TV. They, have a rubber surface or a grid, and then obviously a big object like the sun would make a pretty good-sized dent in that plane of space, if you will.
Right.
Whereas the Earth would make a smaller dent. And yes, as when you look at it from a certain angle, it appears to be waves, especially anything orbiting a big mass. And so, it's these sort of dents in space that space-time that is the way Albert put it, that was so different. Whether or not you can ride them, Jimmy, I mean, you're asking, that's a question that's probably a few hundred years out, but no doubt people will start thinking about that.
What's funny is, Walter, I get phone calls every single night from my audience that want to know or have their own ideas about gravity. And then I have PhDs that I talk to and physicists, and I never get a straight answer. It's a fascinating subject. I don't think they understand fully what gravity is. And to get 20 physicists in one room and astronomers to sit and discuss and try to, come up with a definition that is accepted, I don't think it could happen. I think you would end up in a fist fight.
Yeah. Well, as I think about your question, I'm trying to think of examples, and our planets are kind of riding gravity, if you will. They're pulled in by the sun, and at the same time, there's another force. They're moving so quickly around, they never get too close to the sun, and those forces are balanced, and they're sort of in this gravity track. They're the dent of their own mass that keeps them in place. And this new discovery we're talking about, this large gravitational influence on one side of our universe, is stretching planets, especially small distant planets, stretching them into these long elliptical orbits that are inclined to the plane. And so you can see that things are riding gravity. Gravity is sort of pulling and reshaping the solar system. It's just we haven't completely identified what this big gravitational mass is.
And we have a combination of different things. And help me on this. I just love talking to smart people. I always learn something. We have the gravity when you walk outside of your house and you drop a tennis ball and it hits the ground. We have that. We have gravity at the atomic level. We have the gravity that is keeping Earth in its position relative to the sun. We have the gravity that's keeping the moon out around our Earth, right? And it just keeps on going. And then we have the theory of gravitational waves moving through and also changing. And then we have the gravity that is affected out one more layer, like this additional planetary body. Are they all the same? The atomic level, what's keeping the water on planet Earth from spinning off into space, and then Earth around the sun and our solar system and its planets. It's very confusing.
It is confusing, and gravity is one of those things that you can measure pretty accurately. You know that it falls off with distance at a very measurable rate, but nobody knows exactly what causes it. We know it's related to mass, but you still don't know what causes it any more than we know what causes a magnet to pull. We can, again, measure that. That falls off even faster than gravity, but nobody knows what causes that. And so I think we probably need to learn a little bit more before we can actually harness it, in my opinion.
And how does it affect us here? That's the big question, and I know this is something that you talk about quite a bit. If we have Planet 9 out on a 20,000-year orbit and its gravity affecting our solar system, obviously, and then we have gravity waves coming through, what does that mean to us? Why is it such an important discovery on both counts?
Well, for me, I'm always interested in these cycles of time, cycles of history, and there's a couple of really obvious ones because they repeat so often relative to our lifespan. And the first one, of course, is the Earth spinning on its axis. So it spins. We're all adapted to it. And so, in a few hours, we'll all be in a subconscious state because our bodies are used to sleeping when there's not much of the electromagnetic spectrum being received from the sun. It's dark. Versus when you get a lot of those rays, our bodies are adapted to awaken and be more active. Photosynthesis occurs. It causes lots of stuff to happen, just that first celestial motion. And so there's another celestial motion that's even bigger, of course. That's the Earth revolving around the sun in 365.25 days. And that, because the Earth's on a slight tilt, it causes, more and less light. And so you go from, spring with everything sort of blooming out of the ground to summer, it gives its fruit, and fall, it starts to fall off and wither. And winter, it appears to be dead, only for the light to reemerge and everything come back to life. And it's not only that. I mean, it's not only trillions of plant forms, but it's billions of other life forms that will spawn or migrate or hibernate in mass. And so those are just our first two celestial motions. They have dramatic effects on life, and yet we hardly even talk about it because it's so familiar to us. So if there is a third celestial motion, our entire solar system going around a big gravitational mass, which
right.
appears that there is,
right.
Then it starts to lend a lot of credence to all these ancient stories about the rise and fall of civilization, something Plato called the Great Year, and something that, Giorgio de Santillana, the former professor of the history of science at MIT, and
right.
Wrote about in Hamlet's Mill, that there are these cycles that come and go, alternating dark and golden ages, and over 30 ancient cultures talked about it. And so that's what fascinates me. Is that cycle just a long-lost myth that happens to be recurring in almost every single ancient culture, or does it really have a basis in fact? And I think we're right on the edge of science in understanding that it has a basis in fact.
Do you think this information is being suppressed?
I don't think it's suppressed so much, Jimmy, as it is these paradigms get to be so darn strong that we ignore obvious stuff right in front of our face. Did you see the movie The Big Short by any chance?
Yes, I did.
Yeah, I mean, fascinating thing, and we're all buying into this idea that houses can only go up in value forever, and so everyone's buying this paper which gets sketchier and sketchier and sketchier, and it's traded, and it's all blah blah blah. It's in all these portfolios, and next thing you know, everybody's dependent on this system, and nobody wants to question it. And it's that way a little bit, and it's why it's so fun when great new discoveries like the ones in just the last few weeks that there might be a ninth planet, because there's got to be some big gravitational influence or gravity waves, and it's going to just open our eyes to something bigger.
It seems to me, Walter, that there's a big chunk of knowledge out there that somebody knows it's there, and we're trying to get to it. As we progress, as we grow older, and as we mature, we are starting to question history and these gaps that are there in our knowledge. Where did the knowledge go? It didn't just disappear. It was certainly handed down through mythology and legend and teaching and mystery schools, and we get that today. But where did the knowledge go? Because 26,000 years ago, and precession or longer, that knowledge of that came from somewhere. Somebody was taught it. Let's take some calls and discuss this, Walter. You want to hang out?
Great. Let's do it.
Let's do it. This is Coast to Coast AM. Our guest tonight is Walter Cruttenton. We're going to take your calls right after this. I'm your host, Jimmy Church. Be right back. I don't know how Australia does it. It must be the water. They crank out the good stuff. ParanormalDate.com has arrived, everybody. Created by George Norrie and Mark Rawlings for the single person in our paranormal world. With now almost 37,000 members, if I wasn't married. The site is now mobile optimized, and it's completely free to join. Check it out today. Just go to ParanormalDate.com. Use the promo code George. That's ParanormalDate.com. Yes, the news broke yesterday. Gravitational waves have been discovered. Albert Einstein referred to this in his General Relativity. It is big news. Our guest tonight is Walter Cruttenton of the Binary Research Institute. We'll be taking your calls right after this break. I'll be right back. Stay right there. Welcome back to Coast AM. I'm your host, Jimmy Church. Sitting in for George tonight. He took the night off. He will be back on Monday. Two of the greatest discoveries have happened in science in the last 2 weeks. We're going to be talking about this for the rest of the night. Follow us on Twitter. Interesting stuff on Twitter, by the way, at JChurchRadio. And I was reading everything right there during the break. You guys are smart. At JChurchRadio. Walter Cruttenton is the director of the Binary Research Institute right here in Newport Beach, California. Walter, you ready to take some calls?
Let's do it.
All right, let's go. I'm going to go in order here. Let's go to Bill up in West Hartford, Connecticut. Bill, welcome to Coast AM. Say hi to Walter Cruttenton.
Yes, hi, Dr. Cruttenton. Hi, this is Bill from West Hartford, Connecticut. I am an amateur astronomer, so I know astronomy and space science and physics as an amateur. And I wanted to ask you a question regarding gravity as well as gravitational waves in relation to what is on the cutting edge of science now in 2016 that we haven't actually proved yet, but we're getting close to, and that's other dimensions and other universes. Other universes would involve the multiverse, and other dimensions in our universe would involve, I think, string theory, where our universe would be really 10 or 11 dimensions, of which 7 or 8 of them are curled up, in our dimension, our universe itself has the 3 dimensions of space and 1 dimension of time. My question specifically that involves gravity, or maybe more specifically gravity waves. Would gravity or gravitational waves be a way of getting information about other dimensions as well as other universes? For example, in the cosmic microwave background, the CMB, from the Planck satellite and other instruments at the South Pole, like BICEP 2, they're looking for information, data, evidence of inflation. If they find certain B-mode gravity waves, which will prove inflation, help to give more evidence on the Big Bang, could these kind of things like gravitational waves and B-modes give us information about other universes that may have bumped into our early universe as well as other dimensions in our own universe?
Hey, that's a great question, Bill, and it is one of the topics that actually came up in the public announcement today. Can gravity waves help us see strings? And of course, nobody knows yet. I think some people are still trying to figure out whether or not this sort of first finding is an anomaly or whether we're going to find a lot more real soon. But it's like having we've just discovered a different type of telescope. It can help us see almost what you would call different dimensions, because remember we were talking about when X-ray and other forms of using electromagnetic spectrum were first discovered rather than just using visible light. It helped us to see things we couldn't see. And I bet the same thing is going to happen with gravity waves. So I'm hopeful, but way too early to say anything.
Thank you for the call, Bill. And that's a very interesting question. And I was trying to discuss this with you earlier, Walter. Bill, stay with us. I'm having a hard time to visualize this. And when you introduce this next idea, it's hard, and I want everybody to try to figure out a way to understand the importance and the significance of what we're talking about. Exactly, but see, Walter, that's exactly my point. It's hard. It's very hard to describe. I had read yesterday 2 different press releases that said this is certainly the most important discovery since, and it's that heavy. And then when you read about it and you see the description and how LIGO did it and certain particles, and they came in waves and they've illustrated it, but it's hard for people to understand how important it really is.
Yeah, it's almost like we've had 5 senses, but we've only been using 4, and we've just discovered that we can now see, but all we're seeing so far is a wall with 1 dot on it.
Right, that's exactly it. Let's go to Jeff in Culver City, California, right here. Jeff, welcome to Coast AM.
Yeah, hi, Jimmy and Mr. Crittenden. Yes, I've always been fascinated with additional planets being discovered, especially rogue planets. I had this weird dream in 2013 where I seen this huge planet that looked like a gigantic metallic sphere, which had massive craters and cracks all around it. This planet was, it resembled a smoldering ball of fire, which was headed, directly towards Earth. That dream was so disturbing, I woke, shaking. But my question is this, Mr. Crittenden. Given these latest discoveries with the possibility of a 9th or 10th planet, as well as the merger of those 2 giant black holes, which cause this gravitational wave, do you believe that there are rogue planets capable of coming up out of deep space and possibly destroying the Earth? And I'll take the answer off there.
Great question, Jeff. Thank you.
Yeah, so, Jeff, that is a good question. I think pretty much every scientist now would accept the idea that there are rogue planets, because there's a lot of solar systems out there. Heck, when I was a kid, we didn't even know that other stars had planets, and now I think it's 60% of sun-like stars have planets, and they just keep finding more and more of them. The count's over 1,000. So it's highly likely that some of those planets, were knocked loose early in the formation of those solar systems, or came too close to a star, and one of the planets was pulled off. So, unfortunately, planets, unlike stars, don't give off very much light, so they're very difficult to see. But yeah, you have to think they're out there. As to whether or not they can come close to Earth, we've got literally billions of comets out towards the Oort cloud that are shooting in towards the sun, going around the sun, the biggest mass here. And that happens year after year. And they, of course, none of them have hit us in recent memory. So I would think it's pretty rare that a collision would actually happen. Space is so big, you can hardly even conceive of it. But just think of yourself in a gigantic football stadium, and there's a grain of sand, and that's the Earth, and then you drop another grain of sand from somewhere on the Earth, from somewhere high up, and it's got to hit that just randomly. So it's pretty rare that it would happen.
Is it possible for a rogue planet to just sneak up on us?
Well, planets are darker, so they would be more difficult to spot. But as things get closer, we do have groups like JPL that look for small objects, and they map them. Sometimes they don't see them until after they have passed Earth, and so we're still at the very, very early stages of this. But I'm sure we're going to, have a much better map of everything in the next couple of decades, and then it'll be pretty surprising how many things are actually buzzing around us.
Next month, read this report yesterday or the day before. I don't know if you read this, Walter, but we're going to have a meteor that is going to, an asteroid that is going to pass by Earth next month, 11,000 miles, projected to be 30 meters across, 11,000 miles. And then they modified it, if you read, or it could be 9 million miles away. And the reason why, and this is what's crazy, the last time it was by here, it passed by during the day, so they couldn't accurately track it. So that's the guess, between 11,000 miles or 9 million, but it's going to happen next month in March. How nuts is that?
That's pretty crazy. And something that size could do some serious damage, too, so...
Yeah, they were saying that it would be similar to what happened in Russia last year, right? And, there were some people that were injured and, of course, windows knocked out. But 30 meters across is pretty big to me. It doesn't seem small.
Yeah. I think that's actually quite a bit bigger than the estimate for the Russian asteroid. But, golly, let's hope that it stays a safe distance away.
11,000 miles. You can definitely see that with the naked eye. Let's go to west of the Rockies, way west of the Rockies. Robert out in Hilo, Hawaii. Robert, welcome to Coast AM.
Hey, what's up, brothers? How you guys doing?
Excellent.
Hey, man. I got one question for you. What happened to the probe that was on Mars? We never hear nothing about that for a long time. And gravity is like, when I was 8 years old, I could jump over one 6-foot fence, and now I say 50. So when I jump over the fence, I got to crawl up the fence. So gravity is the one that wins, yeah?
So first question there is, what happened to the Mars rover? I think it lasted a lot longer than its expected life. But it has batteries, and of course it has some solar cells, but they get very dusty. So I'd have to find out if that was the exact reason that it stopped, or whether or not there was something else mechanical. But it's a machine, and it wears out, and it's difficult to communicate with. But it did last a lot longer than they expected.
Thank you for the call, Robert. And I don't know if you saw yesterday, I certainly posted it, the 360-degree image that is in the dunes over on Mars from Curiosity. And you can grab the image with your mouse and look at a 360-degree view in high def of Mars. And it's an incredible thing to go and play with. Not that it's everybody's cup of tea, but this is the thing, Walter, when you go and look at this, and for Bill, he should go and check this out, is you can see stuff. I'm serious, too. It's one of those, you just kind of scan around and you just look and you're like, no, you know what? That doesn't look right. And you can actually see it for yourself in high def. And you can point up and look at the sky and look at the sun, too, as well. It's pretty interesting. Let's go to a first-time caller line. Let's go to Nancy. She's right here in San Jose, California. Nancy, welcome to Coast to Coast AM.
Oh, thank you so much. I'm so happy and excited to hear this program tonight because I have some information I'd like to give to you.
Go ahead, Nancy. What's that?
Okay. I've been studying the Urantia book. I'm not sure if you're familiar with it.
Sure. Walter, are you? You've read Urantia.
I haven't read the whole thing, but I've certainly heard about parts of it.
Yeah, absolutely. What do you have for us, Nancy?
Okay, well, I've been studying on my own. This is the third time I've read the book, so I finally grasped it that what you guys are talking about, the gravity, what it is a spiritual gravity force that's happening. And I've been meditating for many, many years, over 16 years, and I've experienced already in my meditation going out there in the universe.
And what do you see, Nancy?
I saw all the beautiful planets and stars, and it's just so amazing. You have to experience it.
Did you have, okay, so when we're talking about gravity, Walter, stay with me on this. When we're talking about gravity waves, and as you did this, Nancy, was there a visualization of waves out there in the universe?
Yes.
Really?
Yes.
And did it feel, describe it for us. And then I don't know if you had a question for Walter.
Just about Urantia, because there's so much information there about the universes and the galaxies and super universes, and it just goes on and on. It's just so amazing.
Well, Walter will agree. I'll throw this right to Walter right now. I'll ask the question for you, Nancy, which is, Walter, all of the mythology and the books that cover this over millennia, it looks like somebody's right. You know what I mean? It's coming into focus.
And I would admit that there's a lot of sources of information and knowledge that don't come through, traditional scientific channels. Some of the greatest discoveries, as a matter of fact, have come through dreams. Discovery of the DNA helix. And so I would agree that there's information out there that we don't know. And it appears that you brought this up briefly, Jimmy, before the break, that it seems like we're becoming something larger, but we don't know quite what that is. And I love to look at that in terms of space. First we find out about the Earth and we realize there's a few planets out there. And then we realize, we're in a solar system. Wow. And then we realize, there's a bunch of other stars and they have solar systems too. And each of these breakthroughs sort of leads to, more knowledge. And it seems like we're becoming something bigger. And maybe that's a spiritual concept or not. I'm not sure it's important what we call it, but I do agree there's a big picture there, and we're just at the very beginning of putting this puzzle together.
Thank you for the call, Nancy. Now, Walter, you just touched upon something that I find utterly fascinating, which is this. Science today, in fact, the world today, doesn't use imagination. Imagination got us to where we are right now. Going back to ships, would fall over the horizon and disappear, right? Well, it took the guy with imagination to think about what's happening, or the solar system, or any specific discovery dealt with somebody that was willing to use his imagination and think outside the box when other people around him were saying no. It's not worth it. No, there's nothing there. It's not interesting. They didn't have imagination. And today, I think we seriously lack that. nobody wants to step outside of the box. It takes people like you with imagination to think and then project and say, what if, and then go out and discover it. Am I right?
I tend to agree with you. I think there's a certain political correctness that says we must only operate by, scientific processes, which is fairly myopic right now. Versus, we were talking about Einstein earlier. Golly, he's a guy that used great imagination. But you do have to apply math to it in order to get it to be accepted in a wider scientific circle.
I just got to say, Albert Einstein used his imagination. This is Coast to Coast AM. I'm your host, Jimmy Church, sitting in for George. He'll be back on Monday. Our guest is Walter Cruttenden, taking your calls right after this. Stay with us. How cool is it that you get Rob Halford, UFOs, Albert Einstein, gravity waves, and Walter Cruttenden in one show? That's what I'm talking about. I'll tell you a little quick story. It's going to take 15 seconds. Years ago, I used to work with Rob Halford, and I recorded him alone, the two of us, and he cut vocals sitting in a chair in shorts, and I took off the headphones and listened to him. And he sounded exactly like that. And I realized then I couldn't sing. Catch Beyond Belief, George Norrie's internet TV show, for dynamic discussions on the paranormal phenomena, conspiracies, and all things that we talk about every night here on Coast to Coast. You can check out the current episode right now with David Weatherly and Black Eyed Children. Just go to Coast to Coast AM or BeyondBelief.com. You can sign up for just 99 cents a day for the first month and enjoy hours of fascinating shows. Just go to BeyondBelief.com. I'm your host, Jimmy Church. Walter Cruttenden, Gravity Waves, your calls right after this. Stay with us. Welcome back to Coast AM. I'm your host, Jimmy Church. I'm sitting in for George tonight. He took a day off. He'll be back on Monday. Our guest tonight is Walter Cruttenden. We're talking about gravity waves, Albert Einstein, the ninth planet. And, for me, could E.T. ride that wave here? Or could we ride that wave out to him? I think that is the big question. Let's go back to the phones, Walter. Let's go to Mike, wildcard line right here in Livermore, California. Mike, welcome to Coast AM.
Good morning, Jimmy, and, almost morning for us. Morning for a lot out there. And Walter, if I may call you that.
Yes.
Wonderful discussion tonight. I'm so glad you have allowed me to be involved in it. My question is intelligent design. With this new discovery, my thought is that everything is so interconnected, and that without, like the butterfly effect that they say, the beating of a wing can affect this and that and everything else, but there's got to be an intelligent design out there somewhere in all this, and I think math proves it. The fact that Einstein knew about gravity waves before they happened, that there has to be a design, or do you think it was random, just a big bang, and everything just went chaotic, and then it just came to what it can be? I'd like to hear your thoughts on that, Walter.
Well, I think everything seems to have some kind of a design to it, whether or not we recognize what that design is. One of my favorite words, it's a Greek word called entelechy, and it's that which is inside something that knows what is becoming. And the common example given is a seed. Take an acorn. There's something inside an acorn that knows it is to become an oak and knows how to become an oak. And, many of the great philosophers would say that we too have something like that inside of us. And so does the solar system and the universe have something like that inside of it from the point of the Big Bang. We just don't know what that is yet. It's not as simple as an oak, but it's probably something just as great and wonderful.
Well, I think that just supports what I'm saying about intelligent design, that was put there in place by our Creator whoever that might be, whatever people think. Personally, myself, I'm a Christian. I believe that God created it all. But to me, this is a great discovery. To prove that there are gravity waves out there, because it just fits into the total design of everything. And I thank you again, Jimmy. Thank you for getting me on, and love the show.
Thank you so much, Mike, and a great call, Walter. You know what? He brings up one of the best points, and he didn't even realize it. The Coast audience and the people that look at things outside of the box are really smart, and they're trying to find the answers. This is just a call that came in tonight, and it's somebody trying to find the answers at a very, very intelligent level.
I agree, and it seems to be happening more and more around the planet. So perhaps we're at a neat part of the unfoldment of whatever the design is.
Say that again, unfoldment?
Yeah, I mean, if there is an intelligent design to things and they unfold to be something bigger and serve a larger purpose, it just seems like we're at a point on the planet where there's so many fundamental discoveries that it's a very neat part of the unfoldment. It's sort of like early spring, where
right.
you go from winter and then suddenly, boom, everything's just bursting into something beautiful.
The unfoldment. Consider that stolen, Walter. That's now mine. Thank you so much for that. Let's go to east of the Rockies. Max in Segovia, Texas. Max, welcome to
Hello.
Coast to Coast.
Hello, can you hear me?
Yes, we got you.
Okay, Jimmy, I've called a couple of times before. You probably remember me. I called when Andy was on and then with William Henry. This is my field. I'm self-taught. Paul LaViolette was an expert on gravity waves, still is. You might check into his thoughts on this. Let's see here. Judas Priest, great band. Rob Halpert, I think he had a band called Fight after that. I'm not sure. Is that right?
Absolutely.
Okay, boss. And then you got IntelliKey. I love that word. I learned it in Jumpstart. And I love the way he said, the planet or the solar system could have that too. And I love the Bill and Nancy. I think they were right on track. This planet could be like 3,600-year orbit with Santorini going off 3,600 years ago. Just worried about chemtrails still. Have you heard of the Horizon Project?
I don't think I have.
No, neither have
okay. I studied that some. I think there's a guy from the Binary Place there in San Antonio at Southwest. Is that right?
I'm not familiar with it. What is the Verizon Project?
The Horizon Project.
Horizon.
They studied all the stuff about like Planet X, Nibiru, and then scientifically. And then they had so proven it to themselves scientifically that they went back and studied all the legends and stuff and tried to correlate them. At the Southwest, I think it's Research Institute. I think there was a guy with the binary planet thing. Yeah, most of the stars are binary, like 80% or more. This one coming March 5th, that's an asteroid. First they were saying it might be 10,000 miles near to Earth. And then, let's see, what else?
Well, hey, Max. Max,
but
thank you.
I want to say happy Valentine's Day to all the lovers and lovers-to-be.
Thank you so much, Max. Thank you so much, and have a great night. Let's go to James right here in Los Angeles, California. James on the wild card line. Welcome to Coast AM.
Hello, guys. How are you doing tonight?
Great.
Good. Right away, I started thinking of the Coral Castle in Florida. This guy, you can look it up on YouTube. This guy, Ed Leeds Callan.
Sure.
Some people think he used anti-gravity technology. So my questions are, do these gravity waves that you discovered, do they have a frequency? If so, is there more than one frequency? And if so, could you possibly negate or counteract these gravity waves within maybe like an equal or opposite sound wave frequency in order to move, to make things levitate or move? What are your thoughts on that?
Thank you for the call, James. And actually, that's a great question, isn't it? And what is a wave, first off? Is light a wave or not? And is gravity, if gravity is now a wave, is it not gravity anymore? Right?
Yeah. Well, it seems that certain events can cause gravity waves, and it may even take place on a smaller scale that we just can't measure yet. But yes, in the public release of the information, they actually talk about gravity waves in terms of sound, and made a recording because you can pick it up just with our range of hearing, which is kind of interesting. And so yes, you can play that, and it's on the internet, and it's a little bit of a snap, crackle, and pop. But yes, there's definitely a frequency there, and I don't think the whole full spectrum has been mapped by any means. But yeah, it's one of these tools that we can use then now to discover sort of what else is out there, how big is the universe, what are the hidden structures.
What is the relevance in between I think relevance is the wrong word, I meant to say the repeating of the wave, obviously a crest and it dips because that's how the wave is created. What is the cycle between those right now that they have measured at LIGO?
So it's really, really short. So they played a clip, and I think it was, about a half a second clip, and the wave that passed through the two LIGO sites was actually just a portion of that. So I think it's less than 1/10 of a second, but still, they're measuring this thing very, very carefully so they can spread it out. But you can see the sort of the noise of the planet. There's earthquakes and atmospheric pressures and stuff like that, and that's sort of the normal movement. And then suddenly these bars come along that are swinging back and forth, and they're, probably 5x, 10x what the normal noise is. And it was so distinguished and so identical at two completely different sites that's the waveform that they have determined is, due to these black holes combining some 1.3 billion light years away.
And 1/10 of a second to me is at least audible. It's not a millionth of a second, something that's ridiculous that we couldn't hear. But when we're starting to deal with tenths of a second or a half a second, this is significant. This is something that is not only audible, but you can almost see.
Yes, yeah, and well within the range of our current instruments. And it is audible, and I encourage anybody that's interested to go to the National Science site and play it. They've also played, what the sun sounds like. They've recorded that, but that isn't within our current range of hearing. And so in order to make that audible, I think you have to speed it up something like 50 times because the sun's tone is so low. But this, ironically, is within our range of hearing.
Let's go to Wild Card Kelly out in Florida. Kelly, welcome to Coast to Coast AM. Say hi to Walter Cruttenden.
Hello, Walter.
Kelly?
Well, to get started with, I'm a big fan of Douglas Adams and Dirk Gently's holistic connectivity of everything. And tonight's show has brought me thinking of years of experience that I have with electricity dating back to the 70s, with how the way we use electricity, and finally brought electricity to recognize it as the fourth state of matter, like plasma. Is it possible that there's a new form of electricity that we don't yet know how to even measure, or just a new, I guess, wave form of electricity that affects pretty much the universe? Because from my understanding, a lot of things like galactic swirls and stuff like that can be replicated in the laboratory using plasma forms. And a lot of the people who experiment with plasma say that a lot of galactic things, larger universal things. Hello, can you hear me?
Yeah, we're listening. You've got us on the edge of seats here.
I think I understand the question, and there's actually a scientist we've worked with, and he's spoken at our conference on Procession and Ancient Knowledge, CPAC, and his name is John Daring. He works at a think tank, SARA, Scientific Applications Research Associates, and he has hypothesized that there are actually 5 electricities, and so it's not that far out of thought. It's just that we've just come out of the Dark Ages, 300 years ago, 400 years ago with the Renaissance. And I think, discoveries like the last few weeks that will help us better understand and really determine and prove these things. And that's what we've got to do, prove them sort of beyond a shadow of a doubt and do the math to get it widely accepted and embraced in the consciousness.
Thank you for the call, Kelly. Let's get one more in, and let's go to Bob, west of the Rockies, way west, out there in Maui, Hawaii. Bob, welcome to Coast AM.
Yeah, aloha. Jimmy, it's great to hear you. You're my second favorite host on the show. Actually, we say George is number 1.
And he is, but thank you for the, Bob is a paid...
Yeah, right, I am. Walter, do you remember being out here in Olawala going up the canyon to look at the petroglyphs?
I sure do, Bob.
I'm the guy.
Hey, Walter, hey, Bob, let me jump in. Walter and I talked about this on the air 2 weeks ago, didn't we, Walter?
Yeah, we just barely mentioned it, but...
What are the odds? Yeah, thank you, Bob.
What are the odds that we would meet on Coast to Coast, and then Walter said he'd meet me at the store the next day, and we did.
I remember the whole story. This is fascinating, Walter. This is great. Hey, Bob.
We're probably about out of time, but I wanted to mention, I think this gravitivity thing is like what they used to call the electric universe.
Mm-hmm.
I don't know. That's what
it's kind of funny when we talk about intelligent design, the electric universe, everything being connected and everything done with intention, and discoveries like this happen. It just makes me wonder.
It makes me wonder how Walter and I ever met. I took him up to my house, and he couldn't meet my wife that day because she'd just fallen down and broke her wrist. So she was in pain in the bedroom.
Yeah, well, I figured I was in Maui, and whenever there's an ancient site, petroglyph, I'm on it.
Yeah, I'm so there.
Good to talk to you, Walter.
Yeah.
Thank you so much for the call, Bob. And Walter, really quick, before we run out of time, tell us about CPAC. Where is it? Who's going to speak this time around?
Sure. Yeah, this year it will be at the Westin. That's in Rancho Mirage, California. And it'll take place September 30 through, the first few days of October. There'll be about a dozen speakers, Dr. Robert Schoch, the geologist from Boston University that sort of, put forth a new thinking on the Sphinx and much of Egypt, and now Göbekli Tepe, Turkey. We'll be talking about some of his latest discoveries. Chris Dunn will be there, who you probably know, and we're really trying to investigate how much the ancients knew. So invite people to come, and you can find out more information at CPAC Online. That's CPAKonline.com.
When we talk about, I want to ask you a couple of things directly. When we talk about intelligent design, and we involve not only the thought of gravity and gravity waves, light waves, mathematics, calculations, and we bring it all back to us here on Earth. Do you think, what is your position on this? Do you think there is a creator, that there's somebody really smart out there that has planned all of this in advance? And we're not talking about Darwin, we're not talking about accidents, and we're not talking about evolution, that there's somebody out there really intelligent that is laying out everything for